Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IKMAL bin SAAD. Okay, for this session, I would like to present about end of chapter 1 for fundamental renewable energy with my group members, which is first one is Muhammad WAFIQ bin ZAHARI and Muhammad NIZAM bin Abdul MUBIN. Okay, I'm from the E5B and my metric number is 01DE20F1048. Okay, we go to the next slide for the first question. Okay, the first question is hydroelectric installations are classified by the effective head of water. So list three types of installation commonly in use with their turbine. Example for each installation as well as one suitable turbine runner according to each installation type. Okay, the first one is Francis turbine. Water enters the casing under pressure and guided through a set of fixed or adjustable slots called guide vanes around the casing, which direct the flow of water to the turbine blades or the crank angle. This turbine is suitable for low to medium head application but requires a relatively large quantity of water. Okay, the next one is Kaplan turbine. The inlet is a scroll-shaped tube that wraps around the turbine's wicket gate. Water is directed tangentially through the wicket gate and spirals on the propeller-shaped runner, causing it to spin. Advantages of the Kaplan turbine is that they can be used in very low head application, providing that there is sufficiently large water flow rates through the turbine without needs for and their risk resulting in a negligible environment.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nizam bin Abdul MUBIN. My metric number is 01DEE20F1044 and I'm from DEE 5B. Okay, now I will continue the answer for the question 1. The answer is cross flow turbine. This turbine design is which the water strike the turbine blades transversely across its blades. The cross flow turbine is drum shaped and use an elongated rectangular section nozzle directly against curve based on a cylindrically shaped runner. It resembles a squirrel cage blower. The advantage of the cross-flow turbine is that it maintains its efficiency under varying load and water flow conditions. Also, due to their relatively easy construction, good regulation, and can operate with a very low head of water, cross-flow water turbines are ideal for use in mini and micro hydropower systems. Okay, now for the second question is discuss two potentials of hydroelectric power plant in generating grid scale electricity supply and two environment impact of hydroelectric development with suitable example that have been previously reported in Malaysia. Okay, the answer is small scale hydroelectric generated electrical power of between 100 kilowatt and 1 megawatt. The site this is chosen for SHP is usually river or stream. It is called a run of the river river system. Okay, the second is micro scale hydropower, small home-made run of river type scheme that use DC generator designed to produce electrical power between a few hundred watt up to 5 kilowatt as part of a battery charging uh, start stand-alone system. Okay, now my friend will continue the question.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Wafiq bin Zahari, metric number 01DE20F1043. Today I would like to present the two environmental impact of the hydroelectric development with suitable explain that have been previously report in Malaysia. The first environmental effect is land use. The size of the reservoir created by the hydroelectric project can be widely depend largely on the size of the hydroelectric generator and the topography of the land. Hydroelectric plant in flat area need to require much more land than those in hilly area or chaos. The deeper reservoir can hold more volume of water in small space. Hydro turbine generators, specifically when in the form of a dam, can cause serious damage to the surrounding ecosystem. The second environmental effect is wildlife wildlife life impact. The higher of the water level may frequently change the use of a dam system, which impact the environment of plant and animals, specifically animals that use the water near the shoreline. Then make it difficult of fish to immigrate up or downstream. Fish ladder are sometimes installed to make it easy for fish to travel past a dam, but they still can impede the movement of fish. Okay, next question is by consider the technical aspect below demonstrates the principle of hydroelectric in electricity generation with respect to. Okay, first is generator frequency and voltage control principle. In electrical power system, consumer require constant rate voltage and frequency to achieve the principal limit of constant voltage and frequency. Controller are required in the system. The particular case of hydropower plant operating in a standalone mode, variation of the power consumed on a load side cause the deviation between the produce of a consumed power, uh, resulting in a variable output voltage and frequency. Therefore, a number of the governing system have been implemented to the maintain output voltage and frequency irrespective for very consumer load. The next is generator synchronization using a synchronous jet relay. Okay, the type of synchronous jet relay one of SPAU 140C is a voltage measuring relay designed to be used when two or more power system of generator from a hydroelectric power plant are to be connected together. Both synchronous jet function and voltage jet function also can be used by synchronous jet relay SPAU 140C. The synchronous jet function is used when two separate networks of two electrically interconnected network sections are to be connected together. The voltage jet function is used when the disconnect bus or line in to be connected on energized section for a network. The synchronized check function allows circuit breaker close only if the voltage on both sides of the circuit breaker fully the preset condition as to magnitude, phase, and frequency difference. Thank you. And this slide will be continue to my friend.
Okay, so I will continue for the generator operation with speed and voltage regulation. Okay, for the voltage regulation is a measure of change in the voltage magnitude between the sending and receiving end of component, such as transmission or distribution line. Voltage regulation describes the ability of system to provide near constant voltage. So the voltage output should be constant. For example, if generator produce 100 volt, the regulator will make the output voltage constant depend on our required. The conclusion is hydroelectric can operate more efficiently and safely with the use of regulators. And some of the benefits is increase the lifespan of electrical machine. If machine receive more than required voltage to operation, it could be damaged. And next, obtain accurate output voltage as required. And the third one is high tolerance to system faults and overload. Okay, the next one for the generator speed and voltage regulation with droop. Droop speed control is a control mode used for AC electrical power generators, whereby the power output of a generator reduces as the line frequency increases. It is commonly used as the speed control mode of the governor of a prime mover driving a synchronous generator connected to an electrical grid. The generator from a hydroelectric power plant can work by controlling the rate of power produced by the prime mover according to the grid frequency. The function of droop speed control: when the grid is operation at maximum operating frequency, the prime mover's power is reduced to zero, and when the grid is at minimum operating frequency, the power is set to 100% and intermediate values at the other operating frequencies. This mode allows synchronous generators to run in parallel, so that loads are shared among generators with the same droop curve in proportion to their power rating.
Okay, now I'm going to continue for the question 3, Roman 5. By considering the technical aspect below, demonstrate the principle of hydroelectric in electricity generation with respect to generator parallel operation and load sharing. Okay, load sharing is the process at which a facility operators multiple generators at the same time. In technical terms, load sharing is the proportional division of active power and reactive power between generator set. Benefit load sharing. Reliability. There will always be at least one generator set supporting a load. If an alternator fails at any point, the load will shift to the other generators in the system. Load sharing also makes it easier to handle generator maintenance without shutting down the entire operation. Okay, the second is efficiency. The generator runs most efficiently when the load is between 75% and 100%. If you count a single generator, you likely sacrifice efficiency during period of a low requirement. Balance the load between the preference number of generator at a given time and maintenance efficiency around the clock. Okay, there are three types of load sharing. First one is load sharing. Second, isochronous KW and KVAR load sharing. And the third is cross current compensation. Okay, in hydroelectricity, using a generator in large quantities, therefore they need to make plan to operate the generator as best as possible. So the conclusion: proper generator load sharing is essential for the success of a parallel generator system and in turn for backup power. Okay, that's all from me and my group. Thank you.